Right now, you are moving faster than a jet plane. You do not feel it. You are sitting still, maybe lying down, maybe scrolling on your phone, completely convinced that you are not moving at all. But depending on where you live on Earth, you are being carried through space at speeds up to 1,600 kilometers an hour. Your body has no idea. Your inner ear has no idea. Every single sense you own tells you that you are perfectly still. The real answer to why you cannot feel this is far stranger than you think, and it is about to matter a lot more than you expect. Because right now, you are going to imagine something simple. What if, for just 5 seconds, Earth stopped spinning? Not slowed down, stopped, completely, instantly. 5 seconds does not sound like much. You blink for less than that. But those 5 seconds would not be quiet. They would not be gentle. They would be one of the most violent events in the history of the planet, and you would be standing right in the middle of it. To understand why, you first need to understand what stopped spinning actually means for your body. Earth rotates once every 24 hours. That sounds slow. It is not. At the equator, the surface of the planet moves at roughly 1,600 kilometers an hour. Just to keep up with that rotation. Where you are standing right now, the number is smaller, but it is still fast. Often well over 1,000 kilometers an hour, depending on your latitude. You do not feel this speed because everything around you, the ground, the air, the water, your own body, is moving at the exact same rate. There is no friction between you and your surroundings. Nothing pulls against you. This is the same reason you do not feel the speed of an airplane once it reaches cruising altitude. Steady motion, shared by everything around you, feels like stillness. Now take that shared motion away all at once. If Earth's surface stopped instantly, you would not stop with it. Your body would still be moving at whatever speed your location was traveling a moment before. Physics has a name for this. Inertia. An object in motion stays in motion, unless something forces it to stop. And in this case, the only thing forcing you to stop would be the ground itself, slamming into you at over 1,000 kilometers an hour. You would not simply fall over, you would be launched. Picture the 5 seconds broken apart, one at a time. In the first second, everything unanchored. Every person standing, every loose object on every table, every parked car would be thrown violently in the direction of Earth's rotation, as if the entire planet had slammed on the brakes beneath you. In the second, structures with any real mass, buildings, bridges, towers, would begin to fracture at their base, unable to keep their upper floors moving at a speed their foundations no longer shared. By the third second, the atmosphere itself would still be catching up to the sudden stillness of the ground, generating wind speeds beyond anything meteorologists have ever measured. In the fourth, the oceans, still carrying their own immense momentum, would begin surging over coastlines with a force no seawall was ever built to withstand. And in the fifth second, before you even had time to process what was happening, gravity and friction would begin the long, brutal process of forcing every moving thing on the planet's surface back into agreement with the ground again. Buildings would not survive this either. Every structure on Earth is anchored to the ground, but the moment the ground stops and everything above it keeps moving, that anchor becomes a fracture point. Skyscrapers would shear apart at their foundations. Bridges would crumble as their supports were ripped in opposite directions. And this is only the beginning of the 5 seconds. The atmosphere would not stop with the ground. Air has almost no attachment to solid Earth. It moves freely, which is why wind exists in the first place. If the surface of the planet suddenly stopped, but the atmosphere kept moving at rotational speed, you would experience wind faster than any hurricane in recorded history, faster than the speed of sound in some models. Entire forests would be stripped bare in an instant. Coastal cities would be scoured by wind alone, before a single wave even had time to move. And the oceans would not stay in their basins. Water, like air, resists sudden stops. All that ocean mass moving at rotational speed would surge forward with the force of a supercontinent-sized tsunami, sweeping across coastlines with a violence measured in kilometers, not meters. Entire regions would be underwater within the same 5 seconds that buildings were being torn from their foundations, and wind was flattening everything still standing. There is another piece of this planet's spin that already touches your life more than you realize, even without a single second of it ever stopping. In 1835, French scientist Gaspard Gustave de Coriolis formally described what happens when something moves across a rotating surface, an effect now named directly after him. It is the reason hurricanes spin one direction in the northern hemisphere and the opposite direction in the southern hemisphere. It is the reason long-range artillery calculations have to account for the curve of the spinning Earth beneath them. You have never felt the Coriolis effect directly, not in any way you would recognize, but weather systems the size of countries obey it constantly. If a subtle, permanent rotation can shape something as massive as a hurricane without you ever noticing, imagine what an instant, total stop would unleash instead. You might be wondering how anyone could possibly know any of this, since Earth has obviously never actually stopped spinning. And this is where real science enters the picture, because scientists have already measured what happens when Earth's rotation changes, even by an amount too small for you to notice in daily life. In 2004, a massive earthquake struck near Sumatra, one of the most powerful ever recorded. NASA geophysicist Benjamin Fong Chao calculated that the shifting of mass during that single earthquake actually changed the length of Earth's day, shortening it by a few millionths of a second. In 2011, a similarly massive earthquake struck Japan, and NASA scientist Richard Gross ran the same kind of calculation, finding another tiny but measurable shift in how fast the planet was spinning. These changes are far too small for you to ever feel. You will never notice a day that is a few millionths of a second shorter, but the fact that scientists can measure it at all tells you something important. Earth's rotation is not some abstract idea. It is a physical property of the planet, one that can shift, one that can be calculated, one that is being tracked in real time, right now, by instruments built specifically to notice changes you never could. So if an earthquake releasing only a fraction of the energy needed to move mountains can measurably change Earth's spin, imagine the scale of energy involved in stopping that spin completely, instantly, everywhere, all at once. There is a reason astrophysicists who study hypothetical planetary scenarios, researchers like Neil Commons, who has spent decades exploring exactly these kinds of thought experiments in his published work on alternate Earths, treat questions like this seriously instead of dismissing them as science fiction. These scenarios are not just imagination exercises. They are a way of understanding, in extreme terms, forces that are actually shaping your life every single day, just far too slowly and far too gently for you to notice. Because here is the twist inside all of this. The force keeping you from flying sideways right now is not something separate from you. It is not some outside protection. It is simply momentum, shared perfectly between you and the ground beneath your feet, moving together at exactly the same speed, in exactly the same direction for your entire life. That sharing is so complete, so seamless, that your brain has never once had to think about it. You have never once in your entire life consciously calculated the rotational speed of the ground beneath you just to stay standing. Your body does something far more elegant. It simply trusts that the ground and the air and everything around it will keep behaving the way it always has. This is not just physics. This is one of the deepest patterns of how your brain works. You do not process most of reality directly. You process consistency. As long as the world behaves the way it did a moment ago, your brain treats it as stable, safe, ignorable. It is only when that consistency breaks, when the ground shakes, when a plane hits sudden turbulence, that your body reacts with sheer panic. Because a stability you never even knew you were relying on has suddenly vanished. This is also, in a strange way, the same mechanism behind a feeling you already know. That instant of stomach drop panic on a roller coaster, or in a car that brakes too hard, or in a plane during unexpected turbulence, is your body briefly, momentarily encountering a tiny fragment of what a full stop would feel like. A brief mismatch between your momentum and your surroundings. Multiply that sensation by a scale so large it becomes almost impossible to picture. Sustain it for 5 full seconds, and you get this. None of this is meant to frighten you into staying inside forever. It is meant to reveal something you were never given the chance to notice. Every quiet, unremarkable moment of your life, standing in a kitchen, walking down a street, sitting perfectly still, reading these words, is only possible because an entire planet is moving in perfect, silent agreement with you, second after second, without asking for your attention even once. You do not thank the ground for this. You do not think about the atmosphere moving with you, or the ocean staying where it should, or your own body trusting a system it has never had to question. And yet all of it, every second of stillness you have ever felt, was never actually stillness at all. So the next time you sit down, or stand up, or simply exist in a moment that feels completely calm and completely motionless, remember what is actually happening underneath that calm. You are not still. You never were. You are moving at extraordinary speed, in perfect agreement with an entire planet. And the only reason it feels like nothing at all is because, so far, it always has been.